Okay, this video is all about making the Cronbach alpha. Keep in mind that what this is supposed to be doing is just coming in and saying that if you have a scale, no one is ever expecting you for people to answer the exact same question all the way across. Let me just scoot up and look at one of these. This person here, this person number one on this scale between these different items, they scored kind of in the middle, low, middle, low, 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 middle, 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 or middle. I mean, so they're kind of hanging out there. Let's look at another person. This person scored high, then low, then middle, low, 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 middle, low, low, and then high. Well, for the most part, this is following this, so that line kind of looks like this: low, middle, middle, and then moved around along this line, and then they came back up a little bit more. All it's saying is that people should be somewhat the same. If this person seems to be low, most of their numbers should be low as well. If this person here started off with, find a person who is consistent, you would hope that if this person started with a 4, they're not. They found some internal inconsistencies on these things, but you kind of hope that somebody is mainly 4s and 5s, 3s, 4s, and 5s, and somebody else is kind of 1s, 2s, and 3s. That allows for their individuality. So before we go ahead and merge all of these columns here into just one number and use it for our analysis, we need to see if these things really fit, or if they're consistent, or if one of these things is always low when they typically score high or average on the other things. So to do that, let's go up to analysis, go down to scale, find reliability analysis. So again, analysis, scale, reliability analysis. And then at that point, you move all the pieces over for your scale. So in this case, I'm going to do the very first one here. That means I'm going to grab Q1 through Q5. Those are the 5 parts to the physical appearance comparison scale. And then we just add them. Normally this will be blanked out, so what you need to do is come back up here and check, I want the item, I want the scale, and I want the scale if item is deleted. I don't need to worry about adding anything else, just these 3 up here in the top. And click continue. And then make sure that the model says alpha, which it should always want to do. And then just click OK. And we're going to run into a couple different issues. First of all, it's going to tell you the Cronbach alpha, it only did it for 134 people because 4 people somehow skipped something. No problem. Come back in here, and this is telling me it's 0.537. That's not good. It depends on what your scale is set as. Some people's scales have been tested and they swear they should be at 0.9 or higher. Sometimes people test them and it should be at 0.8 or higher. Other ones, the more items you end in a scale, it'd be pretty likely that if you only had 4 or 5 points, remember this one has 5, that it's probably more likely to be somewhere in kind of the 0.8 or 80% agreement to maybe 0.85. Whereas if you had a scale with 10 items, it's pretty likely that that number would automatically be more like 0.75 or something. It's just harder for 10 things to fit than it is for 5. But 0.537 is a bad number. So we skip past this original part of this thing up here to say, wow, so these people on average scored above average, above the midpoint here, then below, above average, and then right in here. So probably this one right here is going to be some kind of an issue for us. So I slide on down here and I look, but that's also factored in with what the standard deviation is. The section here then becomes the second box down. What if you deleted an item? And what this is saying is that, hey, if you deleted this question, it's actually going to lower that Cronbach alpha even more from a 0.537 down to a 0.278. Because again, the reason you're using a scale is 5 items should be a better predictor than just a single question. So don't get rid of this thing. It makes the scale worse. Get rid of this one. It's about where it was before. Again, right now it's 0.537 on this one. This one, again, it makes it worse. This one, it makes it worse. But removing this one item actually does make the thing go up to 0.768. if you can look at your analysis and go back to the original article, probably look in your methods section. If somebody claimed, hey, because there's so many items, I typically only see a Cronbach alpha as 7 or 0.65, then that's what we use. Otherwise, for this, we're going to try as much as possible to be at least at 0.75 or a number pretty close to that. We'd love it to be higher. And we're making that kind of decision based on the fact that there's only 134 people in this group. If there were 300 people in this group, we'd probably want to use the criteria of 0.8 or 0.85 or higher. So bottom line, if we remove this question, comparing your looks, and kind of throw it out of the total analysis, doesn't mean we'd have to throw it away permanently, just throw it out for now. Our Cronbach alpha, we're going to make our scale be a more consistent predictor for our future calculations. So I'm going to hang on to this output, but I'm going to come on back in here and I'm going to go back to analyze scale reliability analysis. Comparing your looks, that was the one that it told me to get rid of. This one that was the second from the down, comparing your looks, yep. Let's get rid of it from the equation. So we're just leaving these parts to it, these 5, and we're getting rid of that one. Click OK. And now, yep, my scale went up. And now I do want you to note, gosh, I want you to leave both of these together. So that's going to make this thing kind of long. One was the original Cronbach alpha. And then the second one down after we get another one of these red triangles to show that it repeated the process a second time when it went up. We're also looking in here, wow, but if we now went back through and eliminated the second one, the best way for a person to know if they're overweight is to compare their figure to the figure of others. Again, it would go up. But all these other ones are moving them. They're crucial to this thing because these 3 seem to be very, very similar to each other. So what I'm going to do is I'm going to leave this. I'm going to hit save on this output viewer. This is the physical appearance alpha. Let's save that baby. So we can use it for future things. And I'm going to say that if you can remove 1 or 2 things at a time, and it gets your scale pretty quickly to 0.7 or something like that, let's leave it. But if you come back and you look at it a second time, it would go up higher again, especially into the mid 80s or something like that. Then we may want to also consider doing something where we take in the 5 scale items and we went to 4. Now we may want to do something where we take it down to 3. However, if you originally run the scale and it already comes out to be about 0.8 or something like that, we're not going to do anything to remove them. So again, this is kind of a fluid process as to whether we're going to keep them all. First run through, if it's already 0.8 or higher, we leave all the pieces. First run through, if it's a lot less than 0.8, like it's down below 0.7, we got to check this. What happens if we delete something and we got to do something to get it up to at least 0.75 or so. And then we're going to also keep track of if removing a second item at a second stage would actually make it even better. But that's how you go back through. You're going to have to do a Cronbach alpha for your other 1, 2, 3, 4 scales. And then I guess also do it for the 5th one, which is all the social networking ones, to see what we can do with that. Next video will be how to go ahead and combine those as mean averages.